Hey guys, this is Ed for Inductor Cloud. I'm back again with another OrCad tutorial. So first thing we want to do is install OrCad. So go to your browser and you're going to want to insert this link right here, which will be in the description below. And once you've opened that up, you'll come to a prompt here to download the light. It's not really a request, you just have to fill it out and it'll automatically send you an email, like within 5 minutes. So just fill all this out and you'll click submit. Once you click submit, you'll get an email which will ask you, which will tell you to download a file. And once you get that file, you just have to unzip this and open up the setup file. The setup file, I'll just go through it, but there's one thing I cannot stress enough. There is a prompt that will ask you to install it for either the entire computer or just one specific user, for only the current user. Make sure you only do the current user, because if you do it for all the users, you'll never get a simulation to run. It's some weird kind of bug. I had to actually reinstall to get it to actually work. And once you have that installed, you're going to want to open up Capture, which is this program here. So I went a bit fast. And you're going to do your project. So we'll just call this example 1, and you're going to want to use a PSpice analog and click OK. Make sure you create a blank project, and we're ready to start our new project, which is this low pass filter. So the first thing you're going to want to do is, sorry about that. First thing you want to do is just push P, and your screen's not going to look like this. It's going to be blank here with the part list. So you want to load up all those libraries, which all you want to do is click Add Library, click this box here which checks everything, and click Open. Once you do that, it will load for about 2 seconds, and you're ready to start. So the first thing we're going to want to do is put our amplifier in, which is in LF411. There's multiple models, like an evaluation and an op amp. I just use the evaluation model. So you'll double click it and it'll load up onto your mouse. Just put it in the middle. It doesn't really matter where you put it, just how you want to actually design the circuit, just to your preference. The next thing you'll want is 2 DC voltage sources. So you'll just type in VDC. You'll need a positive one and a negative one. And sorry about that. You can drag, if you hold and click on an element, you can just drag it around and put it where you want. So if I want to line it up, you can do that. And with the first one, you'll want to use negative 15 volts. And with the top one, you'll want to use 15 volts, which is going into pin 7. And the negative one is going into pin 4. And now, just a quick tip, you want to close off these 2 pins, pin 1 and pin 5, because we're not using them. And from there, we'll want to put our resistors in. So just put in R, a lowercase r or a capital R. Do not type in resistor, because you'll get this model here, which will do weird things and your circuit won't run properly. So just push R and use the analog model. And we want a resistor here, another resistor here, and I like to put, you don't have to do this one, but I just put it anyways, a resistor for the load. Lastly, we'll need a capacitor for our passive elements. Again, see this capacitor here, you don't want to use it because it's got the PWL comps. I just type in C by itself and you get the C analog. We'll need one of those below your resistor, above, it doesn't matter, they're in parallel. And now we just need our AC voltage source, which is, we'll just type in VAC. And if you want to rotate it, you can just do that. Control R will rotate it for you. Sorry about that. But you just double click it again. I'm going to put my voltage source right here. And it's only going to have 1 volt peak to peak at the amplitude, so you can just leave that as it is. And the last component we're going to need is our grounding. So you'll click this little button here, or you can push G as a hotkey, and you'll want to use the first option, which is 0, caps in. Click OK. Put a ground here, one ground here, one ground here, one ground here, and then one last ground here. So now you can either push W on your keyboard or click here to place your wires, and just run all your wiring through for your circuit. Do that really quickly. Go, and then one last wiring. There we go. So our circuit's all set up. Now we just have to input our values. So for R1, if you did your pre-lab, you'll know that it's, or sorry, for your resistor in the feedback loop, it's 5,000. You can do that, or you can just put 5K. For your capacitor, you'll want 10 nanofarads. And then R2 will be 1,000 ohms. For R3, it doesn't matter what you put it, it's just a resistor at the load. I just put it there because I'm not, well, not really, that's just what I do when I use LPF. So, yeah, it's just an old habit. And now we're ready to simulate our circuit, but first we'll have to set up a configuration file. So we're going to PSpice up here and do a new simulation profile. So we're going to want to just name it anything. Example 2. And so we're going to do an analysis type of an AC sweep. And we're going to want our start frequency at 10 Hertz, our end frequency at 100,000 Hertz, and our points of decay can be at 20. For the points, this thing here, all it does is the lower the value, the less smooth your graph looks. So if you put it at 100, it will be a lot smoother than 20. But I just keep it at 20 because it loads a bit faster. Because I'm not using the best laptop. And then just keep everything else as it is. Click apply and then OK. Now we need to declare our input voltage and our output voltage so that when we go to find our decibels and our phase of the Bode plot, we can input those into a function. So you want to go to place and do a net alias. So first we do our input, Vin, which will go right here. And then we need another one for Vout, which will go here. I'll just put it here for now. Negative volts here. Okay, I'm back. Anyways, sorry about that. I had a quick mistake. I had my voltage source in the wrong position, so I quickly flipped that around. And then what you want to do is put your clips in. They'll come in as this color as a black. You want to put one at VIN, one at Vout. I put 3 here just because I don't know why. For some reason, when I graph mine, it doesn't work unless I do 3 here for some reason. So as you can see, I have it here plotted. But we have 3 different graphs, or 3 different Vouts. So I'm just going to delete 2 of them. I'll get rid of the red one and the yellow one. And we'll open this back up. As you can see, it's only our blue one now. And now we can actually look at the graph. If you look here, we have 6 volts on the y-axis. But we're not looking for that in the lab. They want us to do a Bode plot with either decibels or phase, which is in degrees. So now, the easy way to do this is you're going to want to go into trace and add a trace. And the trace you're going to want to use is dB for decibels, and for your phase is P. So now, I'll do it for the phase one. Sorry about that. I'll do it for the phase one. So you're going to want to make sure that you follow my step earlier where I told you to use a place net alias for your Vin and your Vout, because when it comes to doing this function here, Vout and Vin, which is actually your gain of the amplifier, if you don't do that, You're gonna get an error because the software doesn't know what Vout and VIN, what your two V's are, Vout and VIN. So now we're gonna go back here to add a trace. We're gonna want to do we'll just do the phase, which is P parentheses. And inside there, I will put this little gain formula in the description just to save you some time. And then all you're going to want to do is click OK. And now as you can see here, you have your gain in the phase from 0, or sorry, not your gain. You have your graph in the 0 to 200 in your Y plot. So you're going to want to change that to what the tutorial asks, or the lab asks you to. So you want to go to plot, axis settings, and go to Y-axis. You're going to want to do a user defined. And in the notes, it tells you to plot it from 90 degrees to 180 degrees, and click OK. And there you go. This is exactly what they're looking for in the plot for the lab in question 2. Now, for doing the hertz, not the hertz, sorry, for decibels, it's the same exact thing. You're just going to do an add trace. Use decibels, and again, Control V. You'll hit OK. In a new simulation, of course, you have to close this one and start over, and click OK. And then you'll just again go to your plot and make sure your axis settings are in -20 decibels to 20 decibels. Alright? I wish everyone the best of luck, and I'll see you in the next tutorial.